Welcome to the first part of 8.5, Annuities, Methods of Savings and Investments. So in the previous sections, we looked at interest earned on a lump sum, meaning I invested one amount of money, right? And I don't touch the account ever again. Well, that's different than what an annuity is, or where we invest in smaller amounts over periods of time during regular intervals. Okay, each month, at the end of each year, every 6 months, etc. So we're going to talk about how we determine the value of an annuity. So what is an annuity? An annuity is a sequence of equal payments made at equal time periods. So like I said, every month, every 6 months, every year. The value of the annuity is the sum of all of the deposits plus all of the interest paid or all of the interest earned. So the value of an annuity, we have this formula. That's if the interest is compounded annually. But we really don't need to focus on that one. We can focus more on our general one, which is this right here. So the value of an annuity that's compounded n times per year. So this is our big one right here, okay, is going to be equal to this big old formula. So add it to your formula sheet. So it's the principal times the quantity of 1 plus r over n to the nt minus 1 all over r over n. So parentheses are huge when we're dealing with this formula. The variables still represent the same thing. P is the amount that we're paying each period, or our principal each period you can think of. A is the future value. R is the annual interest as a decimal. N is the number of compounding periods each year. T is the number of years. Okay. I'm not going to worry so much about this first example. It's just showing that these two formulas that are highlighted essentially are the same. Let's just go on to the next page and get some examples in. Okay, this first example. Let's assume that the maximum amount that can be placed into a Roth IRA is $5,000, and we should say $5,000 per year. Assume that you put $1,250 at the end of each quarter. So every 3 months is essentially what you're doing for the next 30 years. Assume an 8% interest rate that is compounded quarterly. So again, I'm putting $1,250 in every 3 months, okay? So in this case, our P, what we're putting in every 3 months is $1,250. This is going to be each quarter, so that's when it's compounded, all right? Compounded quarterly. Our rate is 8% or 0.08, and we're doing this for 30 years, okay? So when we plug into our formula, again, you have to be very careful. So definitely practice this with your calculator. Wherever I have parentheses, you put parentheses, all right? The more, the better, to make sure that the calculator is doing what we want. So we plug in P times the quantity of 1 plus R over N raised to the NT minus 1, close those parentheses, divided by the parentheses R over N. So again, try that on your calculator. Make sure you get what you're supposed to get. And you should get this amount on your calculator, $610,322, and this amount here, okay, 0.6896. Now, technically, they would cut that off at the end of that second decimal, okay, so just kind of be aware of that. All right, so then what if I asked you, well, how much of the money in the account did you put in? Okay, so how much did you put in? Now remember, you're putting $1,250 in every quarter, so 4 times a year. That's where the 4 comes in. For 30 years you were doing this. So $1,250 times how many payments you're making per year times the number of years it's sitting in that account. So you deposited $150,000 over this 30-year time frame. So how much of the money in the account was interest? Well, this is where we can take the future value and subtract what we deposited, our total deposit. So A minus that total deposit is going to equal how much interest was accrued over that time period. So you can see you can do a lot, or you can earn a lot of money just by investing it properly. So we earned $460,322 and some change, 68 cents. Again, we would cut that off after the second decimal. So invest, invest, invest. The next set of examples is we're going to look at is to determine what our regular annuity payment should be in order to reach a future value that we want. So for instance, this example here, assume that you thought the amount in the account in example 3 was too little. That $610,000, you want more. So instead, you wanted it to have $1 million at the end of the 30 years. So how much would we need to put into the account at the end of each year to reach this financial goal? Or it should really say at the end of each quarter. So let's fix that. It should say at the end of each quarter. Okay, because that's what our P value is going to be. So first, what we need to be able to do is to manipulate this equation here. We need to solve for P. So we want to get P by itself. So one thing we could do is we could multiply both sides by that R over N. So we're going to get A times the quantity R over N is equal to that P times that whole thing of 1 plus R over N to the NT minus 1. And now how do we get P by itself? We're just going to divide by that quantity. So P is really equal to A times R over N, all divided by this quantity of 1 plus R over N to the NT minus 1. Okay, so that's how we would get our p-value. So what you want to do is make sure you have this formula on your note sheet as well. So now we go through and we want to find what we should deposit each quarter. So we're still using the same information. R is 0.08, N is 4, T is 30, but this time my future value I want to be $1 million. So now we're using that formula that we just manipulated to find what that P value is, what that payment each quarter should be. So we're just plugging in A times R over N all over the quantity 1 plus R over N to the NT minus 1. Use parentheses again. When you throw this into your calculator, you'll get $2,048 and some change. But remember, in order to make sure I do have that $1 million at the end of those 30 years, we want to round up to the dollar, okay? So what we should really say is we should really invest $2,049 at the end of, or at each quarter, okay? All right, this just leads us to that formula. We've already manipulated and found the formula for P, but again, here it is. And you want to make sure that you put this on your formula card. All right, so this is what the regular payments needed. So that's our P that represents the regular payments. All right, I want you to try this next example on your own and then come back and check how you did at the end. So your parents want to have $100,000 in college fund in 18 years. So they're thinking about you. How large of a deposit do they need to make at the end of each month if the account pays 4.5% interest compounded monthly? Go ahead, give it a shot and see how you do. Okay, so hopefully you were able to pick apart the pieces. The future value is 100,000. R is 0.045. N, it's compounded monthly, and it's sitting in that account for 18 years. So you throw it into the formula up above. Be very careful with parentheses. Okay, throw it into the calculator, and we always round up to the nearest dollar. Okay, so we always round up despite what that is telling us to do. So at the end of the day, each month, our parents should invest or deposit $302 into that account. If you have questions on this section, let me know. We will finish these notes next video.